Alright, change the base lets you calculate any logarithm with any calculator. So you don't have to have one of those fancy calculators that you can type in any kind of logarithm. Change of base says if I have log base b of x, it's supposed to be an n. I can change the base like that. So I take a new base, and I take log base n of x over log base n of b. You choose n. N can be anything you want it to be.
So can you just use it, have it be 10?
Yes. Normally with change of base, we want n to be either 10 or e. I cannot write today. So, most of the time we let it be that so that we can put it in our calculators. But if for some reason you wanted n to be 2, you could change your base to 2. So it works with any base. It doesn't have to be 10 or e. So if I do this one for a calculator problem, I could change it into log 32 over log 4, and that would tell me what that is. Sorry, I forgot to grab my calculator. So log 32 divided by log 4. And if you do it with ln, you'll still get the same answer. Doesn't matter what base you change it to, you would get 2.5. You have to have something for a base. With this one, I changed it to base 10. Yeah. What? No, look at the bottom. That was what we did yesterday. Here's what I just did. Log 32 divided by log 4. If I did it using an ln, I would get the same answer. It really doesn't matter what base you use. So there's your proof. If I use ln, I still get 2.5. Here's another proof. Let me use log base 2. Because some of you were asking if you had to change it to certain things. If I use log base 2, 32 is 2 to the what power? 5. 4 is 2 to the what power? So you can change it to whatever base works for your problem. You will have some problems that ask you to solve these kind of things without using a calculator. So if I was asked to solve this without using a calculator, this is what I would do. Because I can figure out that both of these numbers are powers of 2. So I would change it to log base 2. And then I can solve it without using a calculator. All right, you good with all that? All right. Properties. So these are kind of additional properties to the ones that you guys had yesterday. Okay, first property is if you have two things multiplied together inside of a logarithm, you can separate it into addition. I was going to go through a proof of this, but I doubt many of you really actually care for a proof of this. And we spent so much time arguing at the beginning that I'll just skip the proof of this. If you really want to see a proof of this, let me know and I'll show you. But second rule, I mean, basically, it comes from your exponent rules, because remember, these are just inverses. Remember, whenever you multiply two things together, you add the exponents. That's kind of where this comes from. So whenever you, exponent rule-wise, whenever you divide two things, what do you do with the exponents? Subtract them. So the same sort of thing happens with logarithms. If you're dividing two things, you can change it into subtraction. Again, to save some time, I'm not going to worry about actually writing out the proof, but and the last one just kind of follows from the first one. You can take an exponent and move it to the front. This means I have x n times, right? Well, if I change that into addition, I would have n of them added together. Well, if I have n things added together, that just changes into multiplication. So simplified, that just means you can take your exponent and move it to the front. Okay, so those are your three properties of logarithms. Now, we will see how to actually use those for some for solving, but we're not going to do that today. Today they do some problems that are kind of a stepping stone for the actual problems that we need them for. So you may ask, while you're doing these, what is the purpose? Well, we'll get to the purpose a little bit later. So just realize that these are just kind of stepping stone problems. In themselves, there is no purpose other than just to do them. Hopefully you kind of remember these from last year, or from Algebra 2, wherever you took Algebra 2.
What's the thing at the bottom? Oh, okay.
Okay, expanding just means you're going to take, these are kind of inverses of each other. Expanding means you're going to take this and turn it into something that looks like this. And where we get to condensing, we're going to take this and turn it into something that looks like this. So we're just going back and forth on these. So expanding, I want to take that and drag it out using those properties that I just had. So what I'm going to do is I'm going to go through this and separate it out. So to start with, this is multiplication. So what does multiplication become? Addition. Now I'm going to do this in a couple steps just to, I guess, because I can. This x cubed in here, what do I do with the exponent?
You add it to the front.
Add it to the front. So there's my answer. That's all you have to do in those problems. Okay, so I did a harder one on the next one. If I expand that out, the top ones are multiplied together. I can take the exponents and move them out to the front. So if I start here, this 4 would be moved to the front, and I'd have log base 5 of x. Plus, because this is multiplication, 5 log base 5 of y. And then I start doing division. So minus log base 5 of 25 minus 3 log base 5 of z.
But one of them is plus. No, 25 and 1
Okay. If you want to do that, that's fine. What I have to do is I have to write it like this. Because yes, those two things are multiplied together, so they would be plus, but then I have to subtract that multiplication because that entire thing is divided.
That makes sense.
Mm-hmm.
Can we like simplify, like simplify log 5?
Yep. Yep, that's the next thing I wanted to do. So your division, whenever you have multiple things on the bottom, you can either write it like this, or you can distribute that negative sign through and put a minus sign on both of them. And also this log base 5 of 25 needs to be simplified because that's 2. So I'm going to put a minus 2 minus 3 log base 5 of z. Again, if you want to keep that, your entire denominator in the parentheses, that's fine also. All right, any questions about expanding? I always think of it like the cup game where they have the cups and they, pull the cups up into the pyramid and then they shove them back down into the cup.
Oh,
Yeah, speed stacking. So we just unstacked. Now we have to restack. Or whatever. I don't know. That's what I always visualize it as. Stop looking at me like I'm crazy. Okay. So now I need to condense. So all the additions just become multiplications. The numbers in front become exponents. The biggest mistake I see on these, well, okay. I don't normally see a mistake on this. So let's just write this one out. So log, and then I would have 5 x squared y cubed. Okay, for example 5, this is where I usually see the mistake. The mistake I usually see is whenever there's division, the mistake I see a lot is there's a tendency to put two LNs in here. They put an LN on the top and an LN on the bottom. When we're condensing, there should only be one LN in your answer. Now, since I have a minus sign, I'm going to have a division in here. I have the stuff in front of the minus sign, which will go on top, and the stuff behind the minus sign, which will go on the bottom. Okay, so what should go on top? The X, yes. The 3, what is the 3 going to become?
3, no,
LN. Now, what would have been inside this LN to turn into just a 3? Well, what's the base of LN? E. So there had to be an E in order for the LN to disappear. So e to the what power would become just 3? 3. Right? Log base 5 of 25 became 2 because 25 is 5 squared. So to become just 3, it needed to be e cubed. So I need that 3 had to be an e cubed. So if this would have been, instead of ln, if this would have been log base 5, and there had been just a 3 there, what would have been inside the log base 5? 125. Because it would have been 5 cubed. Okay, what goes on the bottom? And Z. All right, you good with that? All right, most of yours are going to be like this. I tried to make the second example like as difficult as your most difficult problem would be. Go ahead.